students, in this video we'll see how to find the eigenvalues and eigenvectors of a given matrix. Okay, so the knowledge on this will be applied in singular value decomposition later, so please listen carefully. So we'll see step by step how to find out any eigenvalues of any given matrix, and also after finding out eigenvalues how to find eigenvectors. Okay, so first we'll take this matrix. Okay, let us go for first matrix and then we'll try to solve for second matrix. So 5 minus 6, 3 minus 4, this is the matrix which is given. Now if I need to find out the eigenvalues, I need to go with the step where I find out the determinant of a minus lambda I to be equal to 0. Now here the lambda what we have is what the eigenvalues which we find out. This is the eigenvalues which we find out, whereas I whatever we have is nothing but identity matrix. Okay, identity matrix. So the dimension of the identity matrix will be equal to the dimension of the matrix A. Okay, so if we have a 2 cross 2 matrix, then identity matrix will also be 2 cross 2. Now here in this problem this is 2 cross 2 matrix, therefore we have 2 rows and 2 columns, therefore identity matrix I will be equal to 1 0 0 1. This is the identity matrix for this problem which we consider. Okay, so now determinant of a minus lambda I. So first we'll check what is a minus lambda I, so which is equal to 5 minus 6, 3 minus 4 minus lambda into 1 0 0 1. So now the lambda gets multiplied with all the elements here, which is equal to 5 minus 6, 3 minus 4 minus lambda 0 0 lambda. Okay, so this is what the matrix we get. Now you write the a minus lambda I resultant, which is a minus lambda I will be equal to 5 minus lambda. So you are subtracting each element with the another matrix elements, okay, with respect to the position. So here 5 minus lambda, 5 minus lambda, minus 6 minus 0, which is minus 6, 3 minus 0 is 3, minus 4 minus lambda, minus 4 minus lambda. Now we need to take the determinant of a minus lambda I, determinant of a minus lambda I, which will be equal to 5 minus lambda I multiplied by 5 minus lambda, that's it, 5 minus lambda multiplied by minus 4 minus lambda minus of minus 6 into 3. This is how the determinant will be considered. So which is equal to 5 into minus 4 minus 20, minus lambda into minus 4 plus 4 lambda, minus lambda into 5 which is minus 5 lambda, minus lambda into minus lambda which is plus lambda square, minus of minus 6 into 3 is 18, which is plus 18, equals 0. So therefore means we need to take a minus lambda equals 0, therefore a minus lambda determinant would be equal to 0. Therefore lambda square, 4 lambda minus 5 lambda is minus lambda, plus 18 minus 20, plus 18 minus 20 is minus 2, equals 0. Now we need to factorize this and find out the solution of lambda here. So 2 is what? 2 into 1 is 2, whereas 2 minus 2 plus 1 is also equal to minus 1. Therefore I can write this as lambda square minus 2 lambda plus lambda minus 2 equals 0. I can factorize in this way. Therefore if I take lambda common here, I will get lambda minus 2 plus 1. If I take common here, I will get lambda minus 2, which is equal to 0. Therefore lambda plus 1 equals, I'll write this as lambda plus 1 multiplied by lambda minus 2 equals 0, therefore I would say lambda 1 equals minus 1 and lambda 2 equals minus 2. Okay, lambda 1 equals minus 1, lambda 2 equals minus 2. This is the two different eigen values for this particular form. Okay, for this particular problem. So these are the two eigen values. Now let us go in finding out the eigenvectors. Finding out the eigenvectors. To find out the eigenvectors, we normally take A minus lambda I matrix multiplied by the vector x and equate that to 0. Okay, to find out the eigenvectors, we normally take A minus lambda I and then we'll multiply that with x and then equate to 0. Now here we do have two different lambda values, therefore we get two different eigenvectors. Okay, so we have two lambda values, therefore we get two eigenvectors. We get two eigenvectors. Okay, so let us now find out those two eigenvectors. Let us now find out those two eigenvectors. So when lambda 1 equals minus 1, when lambda 1 equals minus 1, so what would be the eigenvectors that we come across? Okay, so we know that A minus lambda I was what earlier? 5 minus lambda. So I'll just write A minus lambda I was 5 minus lambda minus 6. Then we had 3 and minus 4 minus lambda. 3 and minus 4 minus lambda. This is A minus lambda I which we had earlier. Now what I'll do, I'll substitute lambda to be equal to minus 1. Okay, so which is equal to my 5 minus of minus 1, which is plus 1. So 5 plus 1 is 6, minus 6, 3, minus 4, minus of minus 1, right? Minus 4, minus of minus 1. So minus 4 plus 1 is minus 3. This is A minus lambda I when lambda 1 equals minus 1. Now this will be multiplied by x, therefore A minus lambda I into x would be, x is a column vector, if you can see now, 6 3 minus 6 minus 3. Now x is a column vector which will always have, x is a column vector which will always have the number of rows, which is 2 here in this matrix, 2 cross 2, right? The number of rows will be 2 cross 1, which is one column. So we call it as a column vector, therefore it will be x1 and x2. So 6 minus 6, 3 minus 3, which is A minus lambda into x equals 0. Now we need to find out what is x1 and x2, and that would be the first vector when lambda 1 equals minus 1. Therefore 6 into x1 minus 6 into x2 equals 0. Similarly 3 into x1 minus 3 into x2 equals 0. Now if you carefully see this, if I divide this equation by 6, I will get x1 minus x2 equals 0. Even if I divide this equation by 3, I will be getting x1 minus x2 equals 0. Therefore in both the equations we can easily say x1 equals x2. Now what I'll do, I'll just assume x1 to be equal to 1 for finding out the vector x2. Therefore, if I assume x1 to be equal to 1, if I assume x1 to be equal to 1, then x2 will also be equal to 1. x2 will also be equal to 1. Therefore, these are the two vectors that we come across. Okay, when lambda 1 equals minus 1. Okay. So therefore we got two vectors, eigenvectors, which is 1 and 1. Therefore I'll say x1 equals 1 and 1. This would be the first eigenvector which we have got for lambda 1 equals minus 1. Now next we go for the next lambda for lambda 2 equals, what was the lambda 2 which we found? lambda 2 was minus 2. For lambda 2 equals minus 2, what is the eigenvector? Similarly, we go with a minus lambda I into x. So here a minus lambda I when lambda 2 equals minus 2 will be what? So let us find out that. So 5 minus of minus 2, 5 minus of minus 2 will definitely be equal to 7. This is minus 6, okay, because I am substituting minus 2 in the place of this lambda. Then this is 3, this is 3, then minus 4, minus of minus 2 is minus 4 plus 2, which is 2. Minus 4 minus of minus 2, which is minus 4 plus 2 is 2. So now this is what I'll just see that my 5 minus of minus 2 is 7. Okay, so minus 4 minus of minus 2 is 2. So minus 6 and 3. Okay, now this a minus lambda I into x is what we need to know now, which is equal to 7 3 minus 6 2 into x1 into x2 equals 0. Therefore I will get 7x1 minus 6x2 equals 0. 3x1 plus 2x2 equals 0. Okay. One second. Yeah. I think a small correction because what we are getting here, lambda equals minus 1, lambda is equal to plus 2. Sorry, I think this is plus 2. Lambda 2 is plus 2. Okay. So therefore 5 minus 2 is 3. 5 minus 2 is 3. I think there is a small correction. I think while finding out eigenvalue I made a mistake. So this is 3 and this will become minus 4 minus 4 minus lambda, right? So it is minus 4 minus 2, which is minus 6. This is minus 6. This is minus 6 because you will never get a different term. That is what. Okay, so therefore this will be changed. So this becomes 3, this becomes minus 6, so this becomes 3 and this is, so this is again 3x1 minus 6, 3x1 minus 6. So again 3x1 equals 6x2. Here also second equation also it says 3x1 equals 6x2. Now if I assume x2 to be equal to 1, then 3x1 will be equal to 6. So x1 will be equal to 2. Therefore the second vector x2 will be equal to 2 and 1. x1 is 2 and x2 is equal to 1. Therefore the total vector x is now equal to 1 and 1, 2 and 1. This is the eigenvector for the given problem. Eigenvectors for the given problem. Now let us go with the second problem, where this is the matrix which is given 4, minus 2, 1 and 1. Okay, so let us find out what is eigenvalues and eigenvectors for this. So first job is finding out the eigenvectors, eigenvalues. So let us find out what are the eigenvalues that we come across with, and then we'll go and finding eigenvectors. Okay, so similarly a minus lambda I. Now again this is 2 cross 2 matrix, therefore I will be equal to 1 0 0 1. Therefore a is 4 minus 2 1 and 1 minus lambda is minus lambda into 1 0 0 1. So therefore this will be equal to what? 4 minus lambda minus 2 1 1 minus lambda. Now determinant of this A minus lambda is what, equal to 0 to find out the eigenvalues. Therefore determinant of 4 minus lambda minus 2 1 minus lambda equals 0. Therefore 4 minus lambda into 1 minus lambda minus of minus 2 into 1, which is plus 2 into 1 is 2, which is equal to 0. So therefore 4 minus lambda minus 4 lambda plus lambda square plus 2 equals 0. Therefore it is 4 minus 5 lambda plus lambda square plus 2 equals 0. Therefore finally the equation is lambda square minus 5 lambda plus 6 equals 0. Now the two factors here is 3 into 2 is 6, 3 plus 2 is also 5. We can also go with 6 and 1. So minus 6 plus 1 is again minus 5 that you get. So therefore I think we should go with minus 3 and minus 2 are the two factors. So lambda square minus 3 lambda minus 2 lambda plus 6 equals 0. So here if I take lambda common, I'll get lambda minus 3. Here I'll take minus 2 common, so I'll get lambda minus 3, which is equal to 0. So lambda minus 2 multiplied by lambda minus 3 equals 0. Therefore the two vectors lambda 1 equals 2 and lambda 2 equals 3. Now these are the two vectors that we get. Sorry, two values, eigenvalues that we get. Now based on these two values we get two vectors. So we will see that now. So eigenvector when lambda 1 equals 2. Lambda 1 equals 2. Okay, so I will take A minus lambda I now, which was found earlier. What was that matrix? Let us take back 4 minus lambda minus 2 1, 4 minus lambda minus 2 1, and the other element is 1 minus lambda. 1 minus lambda. Okay, now I'll substitute lambda to be equal to 2. So what do I get? A minus 2i, which is equal to 4 minus 2 is 2 minus 2 1, and then 1 minus 2, which is minus 1. After this we go with a minus lambda I into x, a minus lambda I into x, which is equal to 2. As it is 2 cross 2, again x is a column vector with 2 rows and 1 column. So 1 minus 1, 2 minus 2, 1 minus 1 into x1 x2 equals 0. Therefore I get 2x1 minus 2x2 equals 0. x1 minus x2 is equal to 0. Now in both the equations you see x1 and x2 are equal. If I substitute x2 to be equal to 1, then x1 will also be equal to 1. Therefore the first vector x1 equals 1 and 1. So this is the first eigenvector which we have got. Okay, I think I should also say you how to prove this, whether the obtained eigenvalue is correct or wrong, eigenvector is correct or wrong. What you do is you take this eigenvector 1 and 1. Okay, so I got eigenvector to be equal to 1 and 1. Now this 1 and 1 was been obtained when lambda equals 2. Therefore I'll just multiply lambda with x1, which is equal to 2 into x1, which I will get 2 and 2. Right? This is what I verify whether the obtained vector x1 is correct or wrong. What we do is we will try to take x1, and then that x1 I will multiply it with the lambda of where I got x1. So lambda was 2 for x1, right? So I will multiply that 2 with x1. I got 2 into 2, 2 and 2. Now I will take the matrix 4 and the real matrix, the question matrix, whatever it was given, and I will multiply that matrix with the obtained eigenvector 1 and 1. and we'll end up in getting the value whatever we have got here. So here 4 into 1 is 4, minus 2 into 1 is 2, 1 into 1 is 1, plus 1 into 1 is 1. So which is equal to 4 minus 2 is 2, 1 plus 1 is 2. Now this is how we verify whether the obtained vector for that particular eigenvalue is correct or wrong. Okay, I hope you got this. Now let us go and find out the second eigenvector. So let us find out what is eigenvector. Eigenvector when lambda 2 equals 3. We got 2 and 3 are the two lambda values which we have got. So let us find out what is the eigenvector when lambda 2 equals 3. So similarly we will take a minus lambda I, which is 4 minus lambda, and we will try to take a minus 3i. Okay, so which is equal to here 4 minus 3, which is 1, minus 2, 1, 1 minus 3, which is minus 2. Now this will be multiplied with the x1 and x2. So what do we get? Which is equal to 1 into x1 minus 2 into x2 equals 0. 1 into x1 minus 2 into x2 equals 0. Equals 0. Therefore, x1 equals 2x2. In this equation also x1 equals 2x2. Therefore, when x2 equals 1, when x2 is equal to 1, then x1 is also equal to 2. When x2 equals 1, then x1 is equal to 2. So these are the two vectors which we have got, and we would say x2 equals 2 and 1. Now if you take lambda, so lambda you take, multiply it with 2 and 1. Now this lambda is 3, which you got 3 2s are 6 and 3. Now you take the matrix, given matrix in the question is 4 minus 2 1 and 1, 4 minus 2 1 and 1, multiply it with the lambda, multiply it with the eigenvector 2 and 1. So what do you get? Which is equal to 4 into 2 is 8, minus 2 into 1 is minus 2, 2 into 1 is 2, plus 1 into 1 is 1. So which is equal to 8 minus 2 is 6, 2 plus 1 is 3. So this is how you prove the obtained eigenvector is correct or not. Therefore, the eigenvector matrix is now 1 1, this is x1, 2 1, this is x2. Okay, so this is the eigenvectors of this particular matrix. Okay, let us find out the eigenvalues and eigenvectors for this matrix, which is 3 cross 3 matrix. So this is a 3 cross 3 matrix. So let us find out what is eigenvalues and eigenvectors. Okay, so now as usual, to find out the eigenvalues, we normally take the determinant of a minus lambda I to be equal to 0. So now here, if I see the identity matrix I would be equal to, 3 cross 3 identity matrix. So this would be the identity matrix that we get. Okay, so we will use this identity to find out what are the, so it is determinant of A is what? 3 4 minus 2, 1 4 minus 1, 2 6 minus 1, minus lambda into 1 0 0 0 1 0 0 0 1, which is equal to determinant of 3 minus lambda, 4 minus 0 is 4, minus 2 minus 2 minus 0 is minus 2, 1 minus 0 is 1, 4 minus lambda, minus 1 minus 0 is 0, 2 minus 0 is 2, 6 minus 0 is 6, minus 1 minus lambda. Now this is the determinant we need to find out. Now for any given 3 cross 3 matrix, to find out the eigenvalues, okay, for any given 3 cross 3 matrix, 3 cross 3 matrix, to find the eigenvalues, we have a formula. So this is for only 3 cross 3 matrix to find out the eigenvalues. Either you can go on continuing with this determinant and finding out what is lambda values and all. Instead of that, there is a standard formula that we will use to find out the eigenvalues when we have given with 3 cross 3 matrix. So it is lambda cube, okay, minus trace into lambda square, plus minus with respect to diagonals, multiplied by lambda minus determinant of the given matrix, equals 0. This is the formula we use, equals 0, okay, equals 0. Now what is exactly trace? What is trace? Trace is actually equal to summation of principal diagonal elements, of a given matrix, The trace for this particular matrix, which is the summation of the diagonal elements which we have, which is summation of diagonal elements. This is the diagonal element, so it is 3 plus 4 minus 1. So 4 plus 3 is 7, minus 1 is 6. Therefore trace is equal to 6. So this is the trace that we have got. After finding out the trace, now let us go and find the summation of minors with respect to the diagonal elements. I'll just write the matrix here once again. So it is 3, 4, minus 2, 1, 4, minus 1, and 2, 6, minus 1. So now let me go with finding out the minus with respect to diagonal elements, and then I'll add that minus. Now when I take 3, you leave that row and that column, okay. So this row and this column and this row, I'll have 4, minus 1, 6, and minus 1 added with determinant of, I will take this diagonal element now, leave that row and that column, and these are the 4 elements that are left, which is 3, minus 2, 2, minus 1, and then added with, this is the diagonal element which we need to consider. Leave that row and that column, you are left out with these 4 elements, which is 3, 4, 1, 4. So therefore this would be equal to 4 into minus 1 is minus 4, minus of minus 1 into 6 is plus 6. So minus 4 plus 6 is 2, plus 3 into minus 1 is minus 3, minus of minus 2 into 2 is plus 4. So minus 3 plus 4 is 1, plus 4 3 is a 12, minus 4 is 8. So therefore this is equal to 11. We got this to be equal to 11. Now finally we'll see what is the determinant of this matrix. So we'll see what is the determinant of this matrix, which would be equal to 3 into minus 4 plus 6 3 into minus 4 plus 6, minus 4 into 1 into minus 1, minus 1, minus of minus 1 into 2 plus 2, minus 1 plus 2. So 2 minus 1 plus 2, minus 2 into 6 into 1 is 6, minus 4 2s are 8. So this is equal to 6 minus 4 is 2, 2 into 3 is 6, minus 1 plus 2 which is 1, 1 into 4 is 4, so minus 4, 6 minus 8 is minus 2 into minus 2 which is plus 4. So 4 and 4 gets cancelled, so determinant of the matrix equals 6. Therefore, the final equation that we write here is lambda cube minus trace is 6 lambda square plus 11 lambda minus 6 equals 0. Now this is the equation you get. Now to find out the roots of this equation you should use the calculator. So I'll just use the calculator and then find out what are the roots that we get for this. So the first root what we get in the calculator, lambda 1 to be equal to 1, comma 2, lambda 2 equals 2, comma, and the third root is 3. So lambda 3 equals 3. So these are the three roots you get for this particular equation if you use your calculator and try to solve. So you all know how to use the calculator. Go to the mode button in the calculator and choose the cubic equation format in your calculator. There you keep on giving the individual values of this is a equals 1, so this you give 1, and b equals minus 6, give minus 6, c equals 11 you give, d equals minus 6 you give, and then you keep on pressing equals, you will see that you get 3 different values. Okay, so these are the eigen values for this particular matrix. These are the 3 eigen values for this particular matrix. Now let us go and find out what are the 3 eigenvectors. The eigenvectors for the obtained eigenvalues. Now let me take the condition lambda 1 when it is equal to 1. Let me take the condition when lambda 1 equals 1. So what will I get? A minus lambda I. So we all know that the eigenvectors is found by a minus lambda I into x equals 0. So when lambda 1 equals 1, my a minus lambda I will become a minus I, which is equal to 3 minus 1 is 2, 4 minus 2, then 1, 4 minus 1 is 3, minus 1, then 2, 6, minus 1 is minus 2. So this would be the matrix A minus lambda I. This will be multiplied by the column vector matrix x1, x2 and x3, which will be equal to 0. Now with this matrix, let us see how to find out the eigenvectors. So here I'll just write the equation first. So I'll say 2x1 plus 4x2 minus 2x3 equals 0. Then I'll say x1 plus 3x2 minus x2 equals 0. Then I'll say 2x1 plus 6x2 minus 2 times x3 equals 0. I can either go in this way, or I can also perform the row operation on this matrix to further reduce it into a simplest form. So what I'll do is I'll try to take R3 to be equal to 2 times R2 minus R3. So let us see what happens. So therefore it is 2 4 minus 2, 1 3 minus 1. So now 2 times R2, which is 2 times R2 is 2 into 1, minus 2, so which is 0. 2 into 3, 6 minus 6 is again 0. 2 into minus 1 is minus 2, right? Minus 2, minus of minus 2, which is plus 2. So minus 2 plus 2, which is again 0. So I got this 3 rows to be 0 into x1, x2, x3 equals 0. Now the third row is completely 0. Now I will see whether I can make this element to be 0. So let me verify that. So here R2 equals R1 minus 2 times R2. So if I do that, what will I get? So I get 2, 4 minus 2. So 2 minus 2 times R2, which is 0. 4 minus 6 minus 2, right? 4 minus 3 2s are 6. So 4 minus 6 is minus 2. Minus 2 minus of minus minus 2 minus minus of 2 into minus 1. So it is minus 2 plus 2, which is again 0. So this becomes 0 0 0, which is into x1 x2 x3 equals 0. So in these two equations I can say therefore here with these two equations I can easily say 2x1 plus 4x2 minus 2x3 equals 0, and second equation is minus 2 times x2 equals 0. Therefore x2 is equal to 0. We get x2 to be equal to 0. Now in the first equation, if I substitute x2 to be equal to 0, I get 2x1 equals 2 times x3. Now in this equation, if I put x2 equals 0, I get 2x1 equals 2x3. Therefore I will be getting x1 equals x3. If I substitute x1 to be equal to 1, x3 is also equal to 1. Therefore the vector x1 is equal to 1 0 1. This is the first vector what we have got. Now we will try to prove this with the actual matrix that we have, whether this vector obtained is correct or wrong. So the actual matrix what we got is 3 minus 3 4 minus 2 1 4 minus 1 2 6 minus 1 multiplied by 1 0 1. We'll see what do we get. 3 ones are 3 plus 4 into 0 is 0, minus 2 into 1 is minus 2. So 3 minus 2 will be 1. 1 into 1 is 1 plus 4 into 0 is 0, minus 1 into 1 is minus 1. So 1 minus 1 is 0. I'll get 2 into 1 is 2, 6 into 0 is 0, minus 1 into 1 is minus 1, 2 minus 1 is 1. I'll get 1 0 1. Now I have lambda into 1 0 1. What will I get? Lambda is actually 1 multiplied by 1 0 1. I will be getting 1 0 1. Therefore the vector whatever I have got 1 0 1 is perfectly right. So therefore this vector whatever we have got for lambda 1 to be equal to 1 is correct. Okay, so fine. Okay, now we'll go with next lambda, which is lambda 2 to be equal to, so lambda 2 is let us see what we have got, 2. Okay, so let us go with lambda 2 to be equal to 2. So we'll write the matrix, we'll try to write this matrix. Okay, so which is 3 minus lambda 1. So we'll write this again. So it is 3 minus lambda 1 minus 2, then 1 4 minus lambda minus 1, 1, 4 minus lambda minus 1. Then we have the third row, 2, 6 minus 1 minus lambda. Third row is 2, 6 minus 1 minus lambda. So let us go with this now. So when lambda 2 equals 2, so what do we get? This one is 3 minus 2 is 1, 1 minus 2, 1, 4 minus 2 is 2, minus 1, 2, 6 minus 1 minus 2 is minus 3. So this is a minus lambda I into x1, x2, x3 equals 0. So what I get here is 1 into x1. So again, if I want to do row operation, I can do that. So we can do the row operation for this. So what I'll do is I'll take row 3 equals 2 times row 2 minus row 3. So we'll see what we will get. So it is row 1 will be written as it is, row 2 also will be written as it is, row 3 is 2 times R2, 2 into 1 is 2 minus 2 is 0, 2 into 2 is 4 minus 6 is minus 2, and then 2 into minus 2, so minus 2 plus 3 which is 1 multiplied by x1, x2, x3 equals 0. Again we can do further row operation if it is possible. What we do here is we will try to take row 2 to be equal to row 1 minus row 2. So what do we get? We get row 1 will write as it is, row 2 1 minus 1 is 0, 1 minus 2 is minus 1, minus 2 plus 1 which is minus 1 again, 0, minus 2 and 1 which is into x1, x2, x3 which is equal to 0. Now further row operation, if it is possible, you can do it. So what will I do is I'll take row 3 to be equal to 2 times row 2 minus row 3. So we'll see what will happen. I'll get 1, 1 minus 2, 0 minus 1 minus 1. So 0 into 2 is 0 minus 0, so 0. Minus 1 into 2 is minus 2 minus 2 plus 2, so it is 0. 2 into minus 1 is minus 2 minus 1 which is minus 3 multiplied by x1, x2, x3 equals 0. So I think this is the final. So we'll write the equations for this row reduced matrix. So I get x1 plus x2 minus 2 times x3 equals 0, minus x2 minus x3 equals 0, and finally 3x3 equals 0. Therefore x3 equals 0, right? x3 will be equal to 0. So x3 equals 0, due to that x2 is also equal to 0. Due to x3 and x2 is 0, x1 will also be equal to 0. Therefore the second vector is equal to 0, 0, 0. Now coming to the third vector, when lambda is equal to 3, third vector. So with this lambda, we'll see what is the matrix that we get. So it is 3 minus lambda, so 3 minus lambda with 3 minus 3 is 0. Then we have 1 and minus 2, which will be as it is. Then we have 1 and 4 minus lambda, so 1. 4 minus lambda, which is 4 minus 3 is 1 again. Then the third element is minus 1. So here 2 and 6 will be as it is. The third row is minus 1 minus lambda, which is minus 1 minus 3 is minus 4, multiplied by x1, x2, x3. So what do we get? Okay, so we can cancel the third element, so we will do the row reduce operation for this. So row 3 would be equal to 2 times R2 minus R3. So if I do that, what will I get? So I'll be getting, first row you can keep it as it is, 0 1 minus 2. Second row 1 1 minus 1. Third row is 2 into 1 is 2 minus 2 is 0. 2 into 1 is 2 minus 6 is minus 4. 2 into minus 1 is minus 2 plus 4, which is 2. So this is what I got. This multiplied by x1, x2, x3 equals 0. Then so I got so is there any other chance of reducing? So now what I'll do is I'll go with R1 and I'll say R1 would be equal to R2 minus R1. So what will I get? R1, which is 1, 1 minus 1, which is 0, minus 2 plus 1, right? R2 is minus 1, minus of minus 2, which is minus 1 plus 2 is 1. So I'll keep 1 1 minus 1 0 minus 4 and 2. So I'll get x1, x2, x3. Okay, then now what I'll do is I'll try to take R2 to be equal to R1 minus R2. So I'll be getting 1 0 1, 1 minus 1 is 0. So I'll just say R2 minus R1. Okay, so R2 minus R1. So it is 1 minus 0 is 1, minus 1 minus 1 is minus 2, 0 minus 4 and 2, which is into x1, x2, x3 equals 0. Okay, now R3 equals 4 times R2 plus R3. So finally what we get? We get 1 0 1 0 1 minus 2 0. 4 into 0 is 0, so 0 minus 0 is 0, 0 plus 0. 4 into 1 is 4, minus 4, which is 0. 4 into 2 minus 8 plus 2, which is minus 6. So this is the matrix finally we get after reducing. So if I find out what is the vector, I'll just multiply this. So I think 1 into x1 is x1 plus 1 into x3 equals 0. then 1 into x2 minus 2 into x3 equals 0, then minus 6x3 equals 0. Therefore, even in this you see, when x3 equals 0, x2 will also be equal to 0. If x2 and x3 are 0, then x1 is also equal to 0. Therefore, x3 is also equal to 0, 0, 0. Therefore, the total eigenvector whatever we got in this particular matrix is, the first one is 1, 0, 1, and other two are 0. So, therefore, I will try to write the eigenvector matrix here, which will be x equals 1, 0, 1, 0, 0, 0, 0, 0, 0. So, this is the eigenvector matrix, even vector matrix for the given matrix here. Okay. So, these are the eigenvalues, whereas this is the eigenvectors. This problem, we need to find out the eigenvalues and then we need to find out the eigenvectors, okay, of the given matrix A, and then we need to verify the trace equals the sum of eigenvalues, and the product of eigenvalues is determinant of matrix A. So, this is what we are going to do in this problem. So, let us consider the matrix A. So, matrix A is 1, 2, minus 1, 4. Now, first thing is we will find out what is the eigenvalues for this matrix, and then we will find out eigenvectors, and then we will verify the given conditions in the question. Okay. So, we know that A minus lambda I, determinant of A minus lambda I equals 0 to find out the eigenvectors, and we know identity matrix will now be a 2 cross 2 identity matrix. Therefore, determinant of 1, minus 1, 2, 4 minus lambda into 1, 0, 0, 1 equals 0. So, therefore, we will be getting determinant of 1 minus lambda minus 1, 2, 4 minus lambda equals 0. So, if I multiply this 1 minus lambda with 4 minus lambda, and then minus 1 into 2 is 2, which is equal to 0. So, therefore, 1 minus lambda into 4 is 4 minus 4 lambda minus lambda plus lambda square minus 2 equals 0. So, it is lambda square minus 5 lambda plus 4 minus 2 is 2 equals 0. So, lambda square minus 5 lambda plus 2 equals 0. Okay, 1 second, I hope, yeah, there is a small problem. 1 minus lambda into 4 minus lambda, minus of minus, which is plus 2. So, I think this becomes plus 2. So, 4 plus 2 will be equal to 6. 4 plus 2 will be equal to 6. So, this is the equation. So, I will say lambda square minus 3 lambda minus 2 lambda is minus 5 lambda plus 6. So, 3 into 2 is 6, 3 plus 2 is 5. Therefore, lambda into lambda minus 3 minus 2, if I take common, I will get lambda minus 3, which is equal to 0. So, I will say lambda minus 2 into lambda minus 3 equals 0. Therefore, I will get 2 eigenvalues, which is lambda 1 equals 2, lambda 2 equals 3. So, therefore, I got 2 eigenvectors, which is 2 and 3. Now, what I will do, I will try to find out the eigenvectors with this. So, first I will consider lambda 1 to be equal to 2. So, we know that it is 1 minus lambda. So, A minus lambda I into x equals 0. So, therefore, it is 1 minus lambda minus 1, 2, 4 minus lambda into x1, x2 equals 0. So we know that lambda equals 2 now, substitute that 2 here. So 1 minus 2 I get minus 1, 2, 4 minus 2 is 2 into x1, x2 equals 0. So I can say minus x1 minus x2 equals 0, 2x1 plus 2x2 equals 0. So with this I can, in both the equations, if you see, x1 will be equal to minus x2, right? So 2 cancels, so x1 will definitely be minus x2 in both the equations. So therefore if x1 equals 1, then x2 will be equal to minus 1. Therefore this is the first vector for this matrix, which is 1 and minus 1. Now what we'll do is, we'll consider lambda 2 value, which is equal to 3, lambda 2 equals 3. So here again we'll take this 1 minus lambda, so 1 minus 3 is minus 2, minus 1, 2, 4 minus 3 is 1, multiplied by x1, x2 equals 0. So it is minus 2 times x1 minus x2 equals 0, and 2x1 plus x2 is also equal to 0. So therefore in both the equations, if you see, we get 2x1 to be equal to minus times x2. Now here if x1 equals 1, x2 to be equal to minus 2, right? If x1 equals 1, x2 will be minus 2. So therefore the vector x2 is now equal to 1 and minus 2. So we got x1 and x2, therefore the total vector x is what? 1, minus 1, and the second vector is 1 and minus 2, 1 and minus 2. This is the total vector x. Now we'll take the two eigenvalues, which is lambda 1 and lambda 2, which is 2 and 3. Now we'll take the matrix, initial matrix, which is A equals 1, minus 1, 2 and 4. Now there are two questions which is been asked in the question. What is that? We need to prove the sum of trays equals sum of eigenvalues, right? Sum of trays equals sum of eigenvalues. If you take the trays of the matrix, which is nothing but the diagonal elements of the particular matrix. Now this is the trays, which is the diagonal elements of the matrix. Now you add the 2, which is 1 plus 4, which is equal to 5. Now you add eigenvalues 2 plus 3, which is also equal to 5. Therefore this is proved. We can easily say that for any given matrix, if you find out the eigenvalues, sum of all the eigenvalues will be equal to sum of all the trays, either in 2 cross 2 matrix or in 3 cross 3 matrix. Any matrix you take, square matrix you take, sum of trays will be equal to sum of eigenvalues. Second proof is, they say the determinant of matrix equals product of eigenvalues, So this is also true for all the matrices, square matrices. You find out the eigenvalues and you take the determinant of the matrix. The product of the eigenvalues will definitely be equal to the determinant of any given matrix. Okay, so therefore now that is only for square matrix, keep it in mind. So here determinant of this matrix is, determinant of A will be equal to 1 into 4 minus 1 into 2, so which is 4 plus 2, which is equal to 6. Now you take product of the eigenvalues lambda 1 into lambda 2, which will be equal to 2 into 3, which is again equal to 6. Therefore the determinant of the matrix is equal to product of eigenvalues, is what the proof is. Okay, so you take any matrix, these two properties will definitely be satisfied, will definitely be proper, and that is for square matrix when number of columns is equal to number of rows. Okay, I hope with all these videos, I hope with the explanation what I did, you have understood eigenvectors, you have understood how to find out eigenvalues, and these two properties also you have understood, I think. Thank you.